Welcome to a new video lecture. Today we will discuss a very new topic related with the influence line diagram on arches. And this is a continuation of the previous lecture. So even if you didn't watch, please go and watch those lectures. So now we will move on to the today's topic. Here, a 3-hinged arch is given with the supports A and B given and the crown point B, C. And when 1 kilonewton is traveling through this arch, then what will be the bending moment at a point D? When it is traveling through this arch, what will be the bending moment at the point D? And this vertical distance be YD. In the case of arches, for finding out the bending moment, we will consider it as an equivalent beam. We have to convert this arch into an equivalent beam. Okay. So we will consider here in this case an equivalent beam in this format. B will be here and 1 kilonewton is traveling across this, and this is the crown point. Let us assume AB points. So here we can note down that when 1 kilonewton is traveling across this beam, the influence line diagram for the bending moment at the point D will be in this format, a triangle shaped diagram, and the maximum ordinate value will be, if let us assume this distance be Z, the value will be L minus Z multiplied by L minus Z by L. Okay, this is the value. This ordinate we already determined in the case of influence diagram. Okay. So this is the case of first diagram in considering this 1 kilonewton traveling across the beam. Then we have to consider the HY diagram. We know that the bending moment at the point D will be bending beam moment at D minus HY diagram. So finding out the HY diagram, we are going to draw when in the case of we already determined the diagram for influence diagram for ILD for H. Horizontal thrust already determined. The magnitude will be L by 4H. So in the case of HYD diagram, the magnitude or ordinate value will be L by 4H multiplied by YD. And after that you have to superimpose those two diagrams, and it is here given here. So you can now note down that the maximum ordinate value here will be Z multiplied by L minus Z by L, and here the maximum ordinate value will be HYD diagram, L by 4H multiplied by YD. And here the bending moment or influence line diagram will be, this is the influence line diagram for bending moment. The shaded portion will give the influence line diagram for the bending moment. Okay. The remaining portions means here it is subtracting U. Okay. So this is the case related with the bending moment, influence diagram for the bending moment. And if this arch is a parabolic arch, there are two types of arch, and in the case of parabolic arch, the general equation of y equals 4x multiplied by L minus x by L square. Already we studied this equation. So the maximum ordinate value, this HYD diagram, if you substitute the value, you will finally get the value as Z by L multiplied by L minus Z. That means both the ordinate values will remain same in the case of parabolic arch. Okay. So this is the case related with the influence diagram for the bending moment. Okay. Now we will move on to the ILD for normal thrust. How to find out? Okay. So for finding out the normal thrust value, we know that the equation for finding out the normal thrust, let us consider this point BD. We have to find out the ILD for this normal thrust at the point D. The magnitude, the value is going to be B sin theta plus H cos theta. This is the magnitude of normal thrust. And here this V means vertical shear and H means horizontal thrust. Okay. So first of all we have to consider this into two cases. First one is V sin theta diagram, ILD for V sin theta, and second is ILD for H cos theta. You have to draw separately. And we know that for the case of horizontal thrust, the ILD for horizontal thrust will be a triangle diagram, and the value magnitude will be L by 4H. And the case of ILD for H cos theta, you can directly multiply with the cos theta. So L by 4H multiplied by cos theta will give the ILD for H cos theta. Okay. Then coming to the case of V sin theta. The ILD for V sin theta, we can easily draw that when a one unit load is traveling across a beam, the diagram will look in this format. It's this. Z by L here and here, L minus Z by L. This Z means the distance to the point D. Okay. So in the case of V sin theta, you can directly multiply it by sin theta value. Okay. So here the magnitude will be negative. Here it is negative and here it will be positive. So that is given here. And the reaction at the point A will be what? It will be 1 sin theta. And you can also represent it here. The reaction at the point D will be, at the point B will be 1 sin theta here. Okay, you can extend if you want. Okay. So for finding out the ILD for this normal thrust, you have to superimpose this first diagram plus this second diagram. If you superimpose, first you have to draw this diagram, this triangle shaped diagram, that means H cos theta diagram. Then you have to, it is given that it is summation, but here when you superimpose there is a negative case. In that case you have to reverse this diagram. Okay, you have to reverse this diagram. Please look here. Here this is a diagram for H cos theta, and the below portion will come above, and after that the above portion means the positive case will come down. Okay, in this format you can easily draw, and you can avoid this negative portion. The remaining portion will give the ILD for H cos theta for the normal thrust. Okay, the remaining portion, the shaded portion, will give the ILD for the normal thrust. And if you extend here, the value here will be, what will be the value? This will be 1 sin theta, and if you extend it here, the value is going to be 1 sin theta. This portion also will remain unshaded. Okay. So this is the case related with the normal thrust. Okay. I hope the diagram is clear. First of all, you have to draw the H cos theta diagram. Then after that, you have to reverse this diagram. Means here it is a negative portion. So for neglecting this negative portion, we are drawing it in the reverse order. Okay, such that this unshaded portion, the remaining shaded portion will give the ILD for normal thrust. Okay, we will move on to the ILD for radial shear. So in the case of radial shear, the magnitude will be V cos theta minus H sin theta. Okay, so we have to find out the ILD for V cos theta and then ILD for H sin theta separately, and after that you have to superimpose over that. So the magnitude or the ILD for H sin theta will be the same diagram in the previous case we studied, isn't it? So the ILD for H will be, the magnitude will be L by 4H. So in the case of H sin theta, the value is going to be L by 4H multiplied by sin theta. Okay, that is given here, and the magnitude will be positive. The diagram value. Okay, and the case of V cos theta, that means shear force, the value will be in this format. Already we studied this diagram, ILD for vertical shear. Okay, and here the magnitude will be Z by L, and here L minus Z by L, and it is a cos theta, and so we can multiply directly by cos theta. So this is the diagram for ILD for V cos theta, and you can easily find out the ILD for shear force, the reaction at A and the reaction at B. Okay, if you extend, this will be 1 cos theta, and here it will be 1 cos theta. Then you have to superimpose this 1 and this 2, and you will finally get the ILD for radial shear. For that, here let us consider V cos theta. You can take down as this is negative value, and here it is negative. Okay, here negative and here positive value. Okay, and here again going to be positive. So if you substitute negative plus positive, then again it is going to be negative. Okay, so you can directly, if you sum up all these values, you can neglect this positive value. So here you get, you should not reverse in this case. The diagram should not be reversed. Okay. So you can directly draw such that the diagram will represent in this format. Means first of all you can draw this triangle diagram L by 4h. Okay. Then after that, the diagram, second diagram means the negative portion you have to draw. After that, the positive portion. And I already mentioned that the negative portion and the negative portion will be shaded. Okay. That's why here be shaded. And you can neglect the positive portion. Okay. So this is the ILD for radial shear at the point T. Okay. So this is the case related with the bending moment of and then normal stress, radial shear. We already studied how to draw the ILD for horizontal thrust in the previous lecture. So this is the section related with the ILD for arches when a unit load is traveling over the beam. Okay, over the arch. So with this we will wind up today's section. Thank you.